Good day. I'm Dr. Tim Floyd, Associate Professor of Mathematics at Georgia Highlands College, and today we're going to look at evaluating functions where we substitute algebraic expressions. Now, in this case, this is usually a topic that many new college algebra students stumble at, maybe because they haven't practiced things like this a great deal in quite a while. So I hope this video helps clarify some questions and some issues that you may have about substituting expressions into functions. So suppose we have a function f of x equals 2x minus 5. For those of you who may recognize that, that's a fairly straightforward linear function. So if we solve this, I'm going to rewrite the function just a moment, but I'm not going to put anything where the variables are. Okay. Now, keep in mind that when we say a function evaluated at a, then this simply means that we are going to substitute what's inside. In this case, we're going to substitute a in for the f function name and a for the variable x. Now, I generally use parentheses in the space where the variable is. So if I had variable x, I put parentheses as the mailbox, more or less, for the input. Now in this case, we follow order of operations, and we see in this case then that we have 2 times a, which simply is 2a minus 5. Now, there's nothing further that we can do with this, and that would be the result for the first problem. Now, let's suppose we have the function evaluated at negative a. So, in this case, we have 2, and have parentheses where the variable was, and inside of there we're going to substitute negative a. So as we simplify this, we have a 2 times an understood negative 1, so this would make this negative 2a minus 5. Now, if we take the last one then, and we are going to then substitute a plus h in for the variable. So I'm going to put my parentheses, and so we substitute a plus h. And so in this case, we have a distribution to do. So if we distribute the 2 correctly, then we have 2a, or 2 times a, plus 2 times h minus 5. Now, there's no like terms in that, so that would be our final result. Now, these expressions cannot be simplified any further because they have a variable a now in them. And until we know what value we are substituting for a then, and of course the last one also has a variable h, which would have to have a value substituted in order to simplify this to a number. Now we have a different expression. We have a function that has f of x is negative 3x squared plus 2x minus 1. So in this case, we're going to do the same work, but now we're going to do the new function, same inputs that we put on the other problems. So we're going to do f of a, and so in this case then, I'm going to have negative 3 with something squared plus 2 times that something minus 1. And in this position, we're going to substitute our a. Now, if we follow correctly order of operations, in this case, only the a is getting squared, not the negative 3. So what we will have then is negative 3a squared. then we have 2 times 1a, which would just be 2a minus 1. And that would be the result by evaluating the function f at a. Now, if we have the same, except now we're putting in negative a, so in this case we have negative 3 times an inputting negative a that is getting squared, plus 2 times negative a. Okay, now in this case you have to remember that since the negative is inside parentheses with the power affecting everything in parentheses but not the negative 3, then what we'll have here then is negative 3 at negative squared would become positive a squared. Now in the next term we will have a negative 1 times the 2, which essentially then makes this minus 2a minus 1. So you can see the difference in these two results, that they almost are essentially the same except the middle term. When you're putting in a positive a, the middle term stays positive. When you're substituting negative a, the middle term becomes negative 2a. And then, last but not least, we have, okay, I'm going to sit this in right here. We have f of a plus h. So we have, if we go back to the original function, negative 3x squared, so we have negative 3 a plus h squared plus 2 times a plus h minus 1. Now, I'm going to do a little work over here on the side just to save some space. Now that we have a plus h squared to simplify, remember that this is a FOIL. This is a plus h times a plus h, which then if we do first, outside, inside, last, we have a squared plus a h plus a h plus h squared. So we have a squared plus 2ah plus h squared. Now, keep in mind that, to save a little space here, that we had a negative 3 in front of that. So there would be a negative 3 times that once we get it simplified. So what we have then is negative 3a squared minus 6ah minus 3h squared. So we'll squeeze this in. So we have negative 3a squared. Okay. Now, please remember about foiling, multiplying polynomials together, that there are many students who would take this and just simply call this a squared plus h squared possibly, or something else. So you got to be very careful when you're simplifying that. Now, we're not done because we have the positive 2 to distribute. So in this case then we have plus 2a plus 2h minus 1. Now, last thing we would do is look and explore to see if we have any like terms. We have no other a squared term. We have no other term that has a and h multiplied together. We have no other term that has h squared in it. And then therefore nothing with a, just a, or not just h by itself. So this is the result, and depending on your instructor, there could be other ways to situate these terms in a final answer, but this is the result. And then however your instructor would ask you to arrange these terms, that is up to them. All right, this is going to be a slightly different problem. We're going to make our substitutions into this function f of x is 2x plus 1, but then we're not going to be simply have that as an answer. We're going to use that result and other results to simplify this expression. And those of you who've had some calculus may recognize that this is called the difference quotient, and it is very important in our study of calculus. So first of all, we're going to take and do f of x plus h, and in that case then we have 2, and we'll substitute x plus h in for the x that was there originally. And so when we simplify this, we have 2x plus 2h plus 1. There's no like terms, so that is all that we can write for that. Then f of x is simply the function itself. Now the h value is a constant, or some value that is chosen. And so what we want to do then is we want to replace these expressions, or this expression with this result, this expression with the function itself, and then see if we can simplify the fraction. So what we will have then is we will have 2x plus 2h plus 1 minus 2x plus 1, and this is in parentheses because we've got to distribute, and then we have that over h. Now if we follow order of operations, we have this, then we have minus 2x minus 1 over h. Now if we notice that we have 2x minus 2x, and we have 1 minus 1, so those will cancel to 0, or sum to 0 if you want to look at it as that. So what we finish with is 2h over h, and if we can reduce the fraction, because we can reduce the h to 1, sometimes you call that canceling, but it's actually reducing it to 1, so we are left then with a final result of 2. And this is an example then of using what is referred to or as the difference quotient, and by evaluating these functions at the values and then making the substitution of the results back in place of what you evaluated, we can simplify this to 2. And if those of you in calculus, this is a very important step early in the calculus course to be able to evaluate these as you head toward an understanding of what is called the derivative function. So let's do one other like this. This one's going to have a little bit more fun with it. So we're going to do, let me get my pen back here. Okay, we're going to do f of x plus h first. This is going to have a little more work involved. So we're going to have x plus h squared plus 2x plus h plus 1. Now you could go out and this piece, you should understand that this is a FOIL. So if we do that work, you may know it in your head, but we're going to have, it's not just x squared and h squared, it's going to be h plus h times x plus h. So we're going to have x squared plus x times h. In interior, here we have h times x, which we can write as x plus x times h, plus h squared. So we get x squared plus 2xh plus h squared. Okay, so this initially is x squared plus 2xh plus h squared. Now, in this piece, we have a simple distribution to do, so we end up with 2x plus 2h plus 1. Now in this expression, you will notice that there are no like terms to combine, so we'll just simply keep the result like that. The second piece is just f of x, which is the function itself. So now we make our substitution. We have the f of x plus h, okay, which is this result. So we have x squared plus 2xh plus h squared plus 2x plus 2h plus 1. And then we will subtract f of x, which is this function. It's the same as the original given function. So we will have minus, but keep in mind that it's in parentheses. We're substituting it in its entirety, and the negative will get distributed through this. So we'll have x squared plus 2x plus 1. Now we put this all over h. Now, when we simplify the top, what will happen is we will distribute this negative through this expression, and so what we will have then, none of the beginning changes, so we'll have, let me change my pen back, let me do this. Okay, so what we will have then is x squared plus 2xh plus h squared plus 2x plus 2h plus 1 minus x squared. So we'll distribute the negative, so we'll have minus x squared minus 2x minus 1. Again, this is over h. And then, if you'll notice, we have some terms we can deal with in the numerator. So we can do the negative x squared and the positive x squared will sum to 0. The 2x and the negative 2x will sum to 0. And the positive 1 and negative 1 will sum to 0. So that will leave us in the numerator a 2xh plus h squared plus 2h over h. Now we can write these as separate fractions, and by doing this, what we'll be able to do then is reduce each of those fractions, because if you'll notice, there is an h in the numerator and the denominator that we can reduce to 1. So what we're left with then is 2x plus h plus 2. Now, if we reorder this, we can write the 2x. Traditionally, you would write the 2x plus 2 and then plus h. And that would be what we would have. So as you notice, this problem, it has a little more to it, because you're dealing with this function, you're substituting these pieces in, and then you are simplifying. So there's lots of places you have to be careful in here as you FOIL, as you combine the terms, and then as you reduce. So this is an important problem to get correct, and I hope you will practice these and get them correct. I hope this video has given you some help in this subject of evaluating functions with algebraic expressions. If you have any questions or comments, please feel free to email me at tfloydiowens.edu. And I hope you have a wonderful day. Thank you for watching.